Okay. This textbook, page numbers are from page 320 to the bottom of 326. Here, this is rocks and minerals. We've covered that. So 320, 326, and then chapter 13. So that's your next reading. And the other books, what do you have yours?
Chapter 11.
I think you're right. If you happen to have this book, I think it's chapter 11 or chapter 12. Chapter 11. You start with basically on page 374. You skip over to page 384. So 374 and 375, and then skip over 384, and take that to the end of the chapter. Okay, last time we looked at the rock cycle, and basically that's where we ended up discussing the various types of materials found on the Earth's surface. What I'd like to do with the time remaining today is to look at the planet Earth from the inside toward the outer edge. And so what we'll start with at the inside is simply referred to as the inner core. The inner core is unique because it has extremely high temperatures that may reach 94 to 9500 degrees Fahrenheit. 94 to 9500 degrees Fahrenheit. The pressures at the inner core are intense. Pressures are so high that these high temperatures cannot melt the material in the core. The inner core is a solid mass. And the inner core is composed of the heavy elements: iron, primary component; nickel, another component. So heavy elements in the inner core, solid mass, extremely high temp, extremely high pressure within that inner core. And we'll talk about how they ascertain this a little bit later on. As we proceed out, we're not worried about the sizes of these things. As we go up, we have an area that does not have smooth configuration, but peaks and valleys, and that's just the outer core. Temperatures, again, are relatively high. 6,000 to 7,000 degrees Celsius have been reported. The pressures are not so intense. So with the high temperatures, the rock units here are molten. They're molten mass. And literally, it's the movement of materials in this molten mass that gives us our magnetic field. The spinning of the material here results in the formation of our magnetic north pole, magnetic south pole. So this molten, again, it contains primarily iron and nickel, the heavy elements. So we have two of these with heavy elements. One is solid, one is liquid. The bulk of the interior planet Earth is referred to as a lower mantle. And the lower mantle is a transitional zone. It has a fair amount of, in fact, mostly mafic rock types. Mafic rock types are dark, dense materials. So we still have the same kinds of materials here that we have in the core. But in addition to that, we have an introduction of this stuff, SiO2, which is silicon dioxide, but what else would we call it? Quartz. So it's beginning to show up here in minor amounts. This is, again, a solid mass. Then a zone here of just a couple dozen miles is something called the asthenosphere. The asthenosphere is a rather unique region in that it's a solid which exhibits flow characteristics. So it's a solid that exhibits flow characteristics. You're going to say, well, how can solids flow? Well, it doesn't flow like a fluid, but it moves about like silly putty. If you take silly putty, you can pull and stretch and move that stuff around. And it's a solid again. And the asthenosphere is not silly putty, but it's a solid that shows flow-like characteristics. Significant as we began to look further into geologic aspects of planet Earth. Above this, then, again, is a relatively small zone, and both of these are part of the upper mantle. Now, the temperatures in the upper mantle are probably due to radioactivity. So you have radioactivity, you have minerals in here, uranium and other types of materials that are radioactive. So the temperatures here are relatively warm. They're not super hot, they're less than 1,000 degrees. But the temperatures here are basically due to radioactivity in the upper mantle. So the asthenosphere in that part of the asthenosphere is referred to as the upper mantle. Now we have the peeling on the crust, the peeling on the surface. That's the crust. Very, very thin. So on the outside edge we have the crust, and we have two aspects of the crust. Okay, two aspects. We have ocean crust. This is a thin layer, 5 to about 8 kilometers, or if you wish, 3 to 5 miles. The ocean crust is again made up of mafic materials, dark substances. The ocean crust is young geologically. Nowhere in the oceans do we find ocean crust more than 200 million years old. So the ocean crust is relatively young. Then we have continental crust, and typically ranges between 10 and 30 miles thick. It is made up primarily of silicon dioxide.